Let's do 9b. In the Cartesian plane below, a piece of rope is hanging over the top of two vertical poles A, B, and C, D. But we have our key information here. The poles are vertical at all times and are 5 meters in height. The horizontal distance between B and D is 12 meters. Then point E represents the lowest point of the rope. Right, we've answered this, and then we find that our A is equal to 1 over 12. Right, so B, if pole CD is shifted to the right, then what should the horizontal distance between the two vertical poles AB and CD become? So that the value of A is 1 over 100, and the lowest point of the rope is 4 meters above the ground. So there's nothing difficult about this. Let's have a diagram here. Let's say pole CD is shifted this side. Let's say this is the new position of pole CD. Our Y is still 5. It isn't changed, but X has changed. X has changed, right? And then the rope will be like this. So we have the new minimum here. It says, and the lowest point of the rope is 4 meters above the ground. So again, we have in this case, we have what? We have the new E. Let's call the new E. Y at E, which is 4, but we need to find the X at E. B did not shift because the pole AB is not shifting, so this one is still the same. So we have what? We have the value of Q. We can have X and Y here. We need to find the value of P. If we get the value of P, then we'll get the axis of symmetry here. And then using that, we can easily find the distance. Once we find the equation of the axis of symmetry here from the value of P, isn't it, we can find the distance from B up to the axis of symmetry. And then this distance and this distance should be the same, isn't it? Right. So we need to find the value of P here. We need to find the value of P. We're going to use our equation. Y is equal to A, X minus P squared plus Q. What we have our Q, which is 4. Here we can use this point B. Where there's Y we put 5, where there's X we put negative 5. So it's 5 is equal to A. A we have 1 over 100. X is negative 5 minus P squared plus 4. 5 minus 4 is 1. So 1 is equal to 1 over 100. Then negative 5 minus P squared. Then we can multiply by 100 on both sides of the equation. 100 is equal to negative 5 minus P squared. Right, we can square root both sides. Square root both sides. What we get, negative 5 minus P is equal to positive or negative 10. Right, meaning that negative 5 minus P is equal to 10, or negative 5 minus P is equal to negative 10. Right, and then we can transpose P this side and transpose 10 this side. It becomes P is equal to negative 15. P is equal to negative 15. Then if we transpose P this side, negative 10 this side, becomes P is equal to 5. Right. Our rope is in the first quadrant, so it means our X should be positive. So this one is not applicable. We take this one. So it means our P is equal to 5. Right. Let me show you the other way of doing this. At this point here, at 100 is equal to negative 5 minus P squared. You could have maybe expanded this, then get 100 is equal to, if we say negative 5 minus P times negative 5 minus P, you can do this the long way. Using the distributive law, you'll get what? Negative 5 squared, you get 25. In 2 times negative 5 times negative P, you get positive 10P in P squared. Okay, if you expand this, you'll get this P squared, right? And then P squared plus 10P minus 75 is equal to 0. If you write this in standard form, then if you factorize, get P plus 15, then p minus 5 is equal to 0. And then you get your p is equal to negative 15 or p is equal to 5. That's another way of doing it, right? So now p is equal to 5. And then, so it means here is 5, and then this is x is equal to 5. This is our axis of symmetry. X is equal to 5. So now what's the distance here from B to the axis of symmetry? From negative 5 to 5. That is 10, isn't it? 5 minus negative 5, that is 10. So this is 10 meters. Okay, meaning that the distance from the axis of symmetry again to D is also 10 meters. Right. And then now the new distance between B and D will be 10 plus 10, which is 20. Therefore, new BD is 20 meters.